So the next aspect of chemical kinetics we are going to treat now is collision theory. Collision what? Theory. Look at the collision theory. It states that for a chemical reaction to occur, there must be an effective collision between the reacting what? Particle. And this implies that what? Rate of what? Of chemical reaction is depend on what? On the effective collision or depend on what? On the frequency of what? Of effective collision of the reactive particle per what? Per unit time. So the collision theory states that for a reaction to what? To occur, there must be a what? To occur, there must be an effective what? Collision between the reacting or reactant power particle. That is what? Collision what? Theory. This theory, this implies that the rate of reaction is depend on what? On collision of the what? Of the particle per what? Per unit what? Per unit time. And there are two factors that can influence the collision of the what? Of the reacting what? Particle. Factors are the what? Concentration of the reactant as well as what? As the temperature of what? Of reactants. But just know that what the collision theory said that for a chemical reaction to occur, there must be a what? An effective collision between the what? The two reacting particles. If the reacting particles they are not react together, they are not mixed together, nothing will what? Will form. Let me use this as a case of study for collision theory. Assume this blue marker is a male animal, this black marker is a female animal, and the both of them want to what? Want to reproduce in order to what? To produce the new offspring, or in order to produce the copy of them what? Of themselves. So it's a must for what? For this blue and the what? And the black marker to what? To collide together by introducing what? The sexual organ from the male organ to what? To the female organ. So when the two of them collide together like this, that is what? Collision theory. The product of the collision to be the what? To the pregnancy and lead to the what? The new virtus. So that's the meaning of collision. Before anything can be formed, the two reacting particles must be what? Must be collide together. So the product of the what? Of the collision will lead to the what? What we have after the end of the what? Two particles collided together. So the next thing, the collision theory is the one that leads us to the one we call what? Arrhenius theory. Arrhenius what? Theory. And this Arrhenius theory, you can also call what? Activation energy theory. Activation what? Energy theory what? Theory. So the Arrhenius theory, or called what? The activation energy theory, is the theory that is explained the scenario that is happen on what? On collision what? Collision theory. So this theory postulated that for a reactant to transform into a product, the collision particle or molecule of the reactant must possess a certain amount of energy so that to overcome the reactant barrier. And the certain amount of energy, or this energy, is called activation energy. And we use what? AE to what? To denote it. Because according to the what? The Arrhenius theory still postulated that what? For a reactant to transform to a product, the collision of the particle of the reactant must possess a certain amount of energy in order to overcome the what? The reactant barrier, and the certain amount of energy is called what? Activation what? Energy. So what is activation energy now? This activation energy is the minimum amount of energy required for a reactant to what? Or for a reaction to occur. Is what? Is the this activation what? Activation energy is the minimum amount of energy required for a chemical reaction, for a what? A reaction to what? To occur. The energy required for a chemical reaction to occur is called activation what? Activation energy. And the next thing we need to treat is what? Is Arrhenius equation. So Arrhenius equation is a mathematical equation that shows the exactly relationship between the rate of chemical reaction and temperature, which is generally denoted as what? A K equal to the E exponential minus EA over what? RT. This is the stance. And here, where what? EA is active what? Activation energy. And we have what? R should be ID gas constant. T is temperature. A is collision factor. K is rate constant. So, and we can use what? This Arrhenius equation to calculate the what? Activation what? Energy. The function of what? Of this Arrhenius equation is to what? To determine what? Activation what? Energy. And this can be achieved by taking the what? Logarithm of what? Of both what? Both sides. And so what? Let's take what? Natural logarithm. Let's take natural what? Logarithm of both sides. If you are talking about natural logarithm of both sides, simply means what? Ln. This ln means what? Natural what? Logarithm. If it's normal logarithm, it will be logarithm of what? This ln is will be logarithm of logarithm base e of that substance. We call it what? Natural what? Logarithm. So here by taking the natural logarithm of k, we have what? Natural logarithm of a e exponential minus ea over rt. You introduce logarithm. For me, I'm using what? Ln here. I said, whenever I'm using what? Ln simply means logarithm of what? Of that substance base what? Base E. So I'm using ln K. This ln K here means what? Ln logarithm of K base what? Base E. You call it natural logarithm. So introduce what? Ln K to this. Ln A E exponential this. And again, from logarithm, well what? If we have logarithm of PQ, it will give you what? Log P plus log what? Q. Abi? And here, or if you have what? Ln PQ, go to the what? Ln P plus ln what? Q. So I borrowed this statement from what? Logarithm in mathematics. So that was ln K equal to what? Split this. We apply this principle to be ln A plus ln E minus EA R T. This is same thing as this. And the next thing we need here now is what? From law of logarithm again, let me borrow this. If you have logarithm of P exponential A is the same thing as what? A log P. Abi, let us apply it here from this. Let me put where I borrowed this statement from logarithm. Where ln K, what is the what? Ln A, ln what? A. This will come here. You know that what? We have is minus. It will be minus E A R T ln E. This will come like this, and they change the plus to what? To minus. From there again, that's what we call that ln E is same thing as what? Logarithm of what? Of E base E. I said we have ln Galad. Ln Galad is what? Logarithm of Galad base E. So natural logarithm is what? Logarithm of that thing to what? Base E. So, and ln E base E is equal to what? 1. You now have what? Ln K equal to the what? Ln A minus EA RT. Everything here is what? Is 1. We can rearrange this equation to be in what? Ln K should be minus EA RT plus ln what? Ln A. This is the same thing as what? Ln K equal to the what? Minus EA R into what? 1 over T plus ln A. You can compare this statement with equation of straight line as y equal to the what? ms plus c. This is y, this is m, this is s, this is c. So from this now, this is equation of straight line. Our slope here is ea over r. Our s is 1 over t. And now say what? By plotting the graph of ln k against 1 over t, what are we going to have? Graph of what? Ln k against 1 over what? 1 over t. This is what? Here we have ln what? Ln k against 1 over what? 1 over t. What is the slope of the graph here? Minus. And this is slope. We have minus. And I've said it earlier that if you are plotting graph, whenever the slope is minus, the slope is what? Minus, the graph will come like this. I said it from the beginning of this course. But if the slope of the graph is what? Is positive, the graph will go like this. This is a positive slope graph. Abi? And then look at this graph here. This is what we have here. We have minus here. So it tells us that what? The slope of the graph is what? Is minus. And the nature of the graph is what? It will come in this what? In this form. And this particular point here is being what? A, our intercept on the vertical axis, yeah, and the slope or gradient of the curve is minus EA over what? RT. So this is what? The graph for what? Arrhenius what? Equation. So the next thing is what? For two given temperature, for two given what? Temperature.